Hello and welcome. Today we're going to be discussing how to write a polynomial equation from its roots. And want to thank you for joining us. We're presented with a problem that says find a third degree polynomial equation with rational coefficients that has roots -1 and 2 minus I. So, what we're going to do is we're going to use the imaginary root theorem to state all the roots. And what we can do is just rewrite the ones they gave us. So the roots occur at -1, they gave us that, and 2 minus I. And according to the imaginary root theorem, we know that another root is going to occur at 2 plus I, the conjugate of 2 minus I. Alright, next we're going to use the factor theorem to note that the factors occur at, the factors are x plus 1, x plus 1, and then x minus, this root is 2 minus I, and then also x minus, this root is 2 plus I. Okay, so now we have a bit of a monster, but it's not too bad because we're going to be using something called the box method. And we're going to break this down a little bit. We're going to focus our eyes on the right part of the equation, the right hand side here, and we're going to multiply these. We're going to multiply using the box method. So we're going to multiply using the box method, and then we're just going to bring this first factor, x plus 1, we're going to bring that down in just a minute. So if you'll remember when you were learning your times tables, maybe you started like 1, 2, 3, 4, etc. And then down the side you had 1, 2, 3, 4, etc. And you would take 1 times 1 is 1, 1 times 2 is 2, 1 times 3 is 3, 1 times 4 is 4, 1 times 2 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, and so forth. We're going to use the same idea, and we're going to focus on this part. We're going to write this middle term in the top of our box. Well, first, what we need to do, distribute this negative out. So it's going to look like x minus 2 plus I times, distribute this negative out, so x minus 2 minus I here. Alright, so we'll use this for the top of our box. So we'll set our box up like this, x, and then -2 here, and then I over here. Okay. On the side of our box, we're going to have x, this other term, minus 2 here, and minus I here. Okay, so here we go. Just fill in our box. X times x is x squared. -2 times x, -2x. And then x times I is xi. And now we have -2x in this box. And negative times a negative is a positive, so that'll be 4. And then we have -2i here, -2i. And then what we have, negative xi here. Negative times a negative is a positive, so we have 2i here. And then we have I times -I, so we have -I squared. Okay, now, once we have our box filled in, what we're going to do is we're going to add. And we can kind of look at this a little bit diagonally. So the first term, x squared, we'll just bring him down, x squared. And then we have -2x minus 2x. So we have minus 4x. And then in this, in the middle, the negative xi and the positive xi are going to cancel each other out. So we don't worry about those. And we're left with 4. It's a positive 4. So we have plus 4. And then next we have 2i minus 2i, so they cancel each other out. We don't worry about them. And then we're left with minus I squared. Minus I squared. Okay, so we'll just go ahead and write him in there. Now, if you remember, I squared equals negative 1. So let's rewrite this. X squared minus 4x plus 4 minus negative 1. So we could say plus 1. So we are at x squared minus 4x plus 5. Okay? So now that we've multiplied these two together, we can bring this down. So we'll bring him on down here. Ready for him. X plus 1 times this. Now we'll just simply do the box method again. So we can set it up like this along the top. So we have x squared minus 4x. Oops. Let me open up the box a little better so I have room to work. X squared minus 4x. And then we have 5 out here. Okay. And along the side we'll have x. And we'll have 1. Okay. X squared times x is x cubed. X times negative 4x is negative 4x squared. And then 5 times x is simply 5x. And so x squared times 1, x squared. Negative 4x times 1, negative 4x. 5 times 1 is 5. Okay, so we're left with x cubed. X cubed. And then we have negative 4x squared and positive x squared, so we're left with negative 3x squared. And then we have 5x minus 4x, so we're left with just 1x, a positive x, and then we have 5 here, plus 5, alright, equals 0, and then we're all set. So, we have solved what they asked us. Let's go back to the beginning. A third-degree polynomial equation with rational coefficients that has roots of -1 and 2 minus I. So this is our solution. X cubed minus 3x squared plus x plus 5 equals 0 is our solution. Okay, so I think we will actually have time to do one more example. Our next example says, find a fourth-degree polynomial. A fourth-degree polynomial. So we know we're going to have x to the fourth in our solution, right? A fourth-degree polynomial equation with rational coefficients that has roots I and 2i. I and 2i. Okay, so the same thing is we're going to use the imaginary root theorem. Let's rewrite our roots. Roots are I. They gave us I. If we have I, we know there's another root at negative I. And then they gave us a root of 2i. So if we know the conjugate of that is going to be negative 2i. Alright. Then we can use the factor theorem and say, therefore, the factors are x minus I, x minus I, x plus I, and then we have x minus 2i and x plus 2i, x plus 2i. Okay? So, several ways we could do this. We could FOIL, but if we notice real carefully, both of these are set up, and this is the neat thing that happens when you just have I or a coefficient in front of the I. you develop a pattern here and here. Both of these are, if you'll notice, difference. It's the difference of squares. If you notice the pattern, okay, you can always FOIL it out, and algebraically it's just a little bit more work. Well, actually quite a bit more work, but you could do it that way as well. But if you notice the pattern, so for example, let's take this first set here. We have x minus I and we have x plus I, right? If we went ahead and FOILed that part out, we'd have x times x, so that would be x squared, and then x, so that would be plus xi, right? And then minus xi here, minus xi. So what these are going to cancel out. Negative times a positive is a negative. So then we have minus I squared. All right? So the middle terms cancel out. X squared minus I squared. So your pattern in difference of squares is you have your first term squared and then your last term squared and then the minus in between, because it's the difference of squares. So this one's going to work the same way. So we're going to have x squared here, finally, without rewriting this part of it. We're going to have x squared, what, minus this term, 2i, that quantity squared. So we would have x squared minus 2 squared I squared. So 2 squared is 4I squared. Now, let's remember, as in before, I squared equals negative 1. That's our little reminder. So if we look at this side, we're going to have x squared minus what? Negative 1. Minus negative 1. So it's x squared plus 1. And then here we have x squared minus 4 times negative 1. X squared minus 4 times negative 1. So we have x squared, what? Plus 4. X squared plus 4. So now what we've done, we've kind of simplified it out a little bit. So now we need to multiply these two back together. Here we split them apart. Now we're going to bring them back together. So let's just rewrite it, x squared plus 1. And then we have x squared plus 4. And we could just simply FOIL him out. X squared times x squared, x to the 4th. X squared, what, times 4. So we have plus 4x squareds. 1 times x squared is just simply plus x squared. And then 1 times 4 is 4. Combine like terms. X to the 4th. X to the 4th plus 4 and 1 is 5. 5x squared plus 4, and there we go. So equals 0, and we're all set. So a 4th degree polynomial equation with rational coefficients that has roots I and 2i is x to the 4th plus 5x squared plus 4 equals 0. Thank you so much for your time. I appreciate it, and we'll look forward to seeing you on the next segment.